Hello everyone, welcome back to ANR Academy. See, there are two second degree equations, one is h equal 0 and the other s equal to 0, and both represent pair of straight lines. Then observe this table, it represents conditions, the quadrilateral become square, rectangle, rhombus. We know that the definition of parallelogram, a quadrilateral in which opposite sides are parallel and equal in length. That is the basic definition. And here observe four quadrilaterals, they are of equal in length opposite sides particularly, and they are parallel also. When opposite sides are parallel and equal in length, then only they are parallelograms. All the four figures whose opposite sides are parallel also equal. So these four represents parallelogram. Particularly, depending upon some different conditions, they are called rectangles, square, rhombus, etc. Observe the second and third figure. Angle between adjacent sides clearly 90 degrees. So these two figures are called rectangles. Not only this one, these two are called rectangles. Next, here observe, all the four sides are equal in length. Of course, they are opposite sides are parallel as well as they are equal. When the four sides are equal in length in a parallelogram, then they are called rhombus. Both represent a rhombus. And in particular, whenever adjacent sides with an angle 90 degrees, it is known as square. And for both, angle between diagonals is 90 degrees. And here, angle between diagonals not 90 as well as angle between adjacents also not 90 degrees. But these four figures are parallelograms. Remember, these two are rectangles and these two are rhombus. Particularly in these two rectangles, whenever all the four sides are equal in length, it is known as square. Rhombus, four sides are equal, and whenever here, whether it is angle between adjacents 90 or may not 90, but diagonals 90, then these two are rhombus. Especially both 90, then it is called square. Let us discuss how these conditions to represent square, rectangle, rhombus with proofs. See this figure. There is homogeneous equation and there is general second degree equation. Homogeneous equation that satisfies origin. If you substitute x value 0, y value 0, it satisfies, so it passing through origin. These two pairs, pair of lines, represent h equal to 0. And another two, this pair indicates general second degree equation in terms of x and y. Why? Because if you write x value 0, y value 0, it doesn't satisfy. Why? Because you have constant there. So that doesn't passing through origin, and their intersection hf minus bg by ab minus h square, gh minus af by ab minus h square. And here, observing all the figures, we decide the given figure square, rectangle, rhombus depending upon angle between adjacent sides and angle between diagonals. Let us discuss what is angle between adjacent sides and what is angle between diagonals. First, about adjacent sides. Adjacent sides from h equal to 0, this is angle between adjacent sides. Nothing but that is angle between pair of lines. We know the formula for angle between pair of lines, cos theta equal to mod a plus b by root over a minus b whole square plus 4h square. When theta equal to 90 degrees, particularly 90, then this result becomes 0 and hence a plus b 0. So if adjacents are perpendicular, then you have to write the condition a plus b 0. Let us observe in all the cases. Square, adjacents always perpendicular, so a plus b 0. Rectangle, also adjacent perpendicular, a plus b 0. Rhombus may or may not adjacents perpendicular. So here two conditions are there, whether a plus b 0 or a plus b non-zero. Let us move to another condition, that is angle between diagonals. Here one diagonal clearly O dash and the other diagonal this dotted line. This dotted line equation can be written as s minus h equal to 0. Why? Because this line is passing through point of intersection of pair of lines h equal to 0 and s equal to 0. Both h equal to 0 and s equal to 0 intersection. Here you have 2 points, and passing through these 2 points you have the diagonal, so that I am going to write the equation as s minus h equal to 0. S and h both having same second degree terms, and it is having extra first degree terms and as well as constants. When you subtract h from s, second degree terms gets cancelled, only we get 2gx plus 2fi plus c equal 0. This is one diagonal, and O dash is other diagonal. Depending upon the condition perpendicularity, they decided as square, rectangle and rhombus. See, we know that when the two lines are perpendicular, their slope product become minus 1. Here slope of first line, that is here the diagonal 1, this one, applying slope formula, minus of coefficient of x by coefficient of y, minus 2g by 2f gives the result minus g by f. That is you have here. Next another line from O dash, this is slope. See here, O dash you have hf minus bg by ab minus h square, gh minus af by ab minus h square, and the other point is origin. Applying the formula y2 minus y1 by x2 minus x1, what we get? Gh minus af by ab minus h square. From that you have to remove 0, so the same we get. In the denominator part, this one minus 0, the same abscissa you will get here. Both having the same denominator part ab minus h square, they get cancelled, and we get slope gh minus af by hf minus bg, that you have here. Slopes product clearly minus 1 when they are perpendicular. Neglecting negative sign, multiplying with g and f in the numerator and denominator part, after cross multiplication you will get this result. So this is the condition for diagonals to be perpendicular. H of g square minus f square equal to a minus b into gf. This is the condition when the diagonals are perpendicular. Observe here, square, diagonals perpendicular, so that here equality holds. Rectangle, diagonals not perpendicular, equality doesn't holds. Rhombus, diagonals perpendicular, so that equality holds. So these are the conditions to check whether the given quadrilateral becomes square, rectangle, rhombus. And particularly, if both the conditions are doesn't satisfy, then it is generally a parallelogram. Specifically, diagonals not 90, rectangle, but diagonals 90, adjacents not 90, rhombus. Particularly both perpendicular, then it is square. So with the help of just two conditions, just by seeing h equal 0 and s equal 0, first you have to write the value of AB as well as HGF. With the help of AB and HGF, just cross check the two conditions. If the two conditions, depending upon these two conditions, you can decide whether the quadrilateral square or rectangular rhombus or parallelogram, right? So this is the way of verifying given equation represents a parallelogram, and I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.